Now we will discuss how images are formed in various types of mirrors. We will be dealing with the three types of mirrors: plane mirror, spherical concave and spherical convex. First one we will consider a plane mirror. In a plane mirror, image formation is generally very easy. You are used to see yourself in a plane mirror and you know the basic idea. The image formed will be always of your size, and the image distance, the image is behind the mirror as much as you are in front of the mirror. You know all these ideas. Fine. Let us work out this through a ray diagram. This represents a plane mirror. This is the non-reflecting side, this is the reflecting side. Now consider that there is an object here. Objects are generally marked as a vertical arrow mark, and I call this object as A, B. Okay. Now this is a plane mirror. Consider one light ray from the point A, and this will fall normally on the mirror. Right. Now this is known as normal incidence. This is parallel to the normal here. Angle of incidence is 0. This light ray will simply bounce backward. It will reverse its path. So the ray going to the right side will return to the left side, and this will go like this. It will go. Fine. Take one more ray from the same point A and allow that to fall like this at a particular angle. Right. At this point you can draw a normal. This is the normal at that point. Now this is the incident ray. This angle is the angle of incidence. This will obey law of reflection, and that will make an equal angle, and this will bounce in this direction. Okay. Now you got two rays coming. So there is one light ray. There is one light ray which is coming in this direction, and there is another one coming in this direction, and you are observing from this side. When you observe from this side, you know these two rays will never meet to make a point. They will not make an image on this side. They can't converge. So what will happen? The observer, while looking from this side, for this observer, this light ray will be appearing to be coming from behind the mirror. Similarly, this will also come behind the mirror for that observer. And how to get that position? That you can get by extending this backward. I am using dotted lines to show that these are not real light coming from. Okay, this will also come from some point, dotted line, and here these two dotted line, there is some problem in my geometry, please forgive that. When you do that in your notebook, you can make it right. This will come from this point. So you have a point A on the object, and this point becomes the image of that point. I'll call it as A dash. Similarly, you can work out for every point on the object, and you will get a lot of other points just below this one. So different points will be formed here, and the point B will have its image here, and I will call this as B dash. So that gives you the image. So I can just make it complete. So that is the image. AB is the object, A dash, B dash is the image. Now by using geometry, you can see that these two triangles, this triangle and this triangle, they are similar and congruent, and you can say that the distance from the mirror to the object, I call it as U, this distance, and this distance V, this U and V will be equal. U is equal to V in the case of a plane mirror. What does it mean? The image distance and the object distance are equal, but there is one problem. How to apply Cartesian sign convention here? According to Cartesian sign convention, the incident direction must be taken positive. And what is the incident direction? This is the object, light from the object falls on the mirror, so this becomes the positive direction. So what about U? Therefore, the object distance is minus U. Why minus? Cartesian sign convention. What about image distance? Image distance for the plane mirror is plus V. Why is it plus V? Because you are measuring it from the mirror to the direction of the incident light. So U is negative, V is positive. We know magnification is given by minus V by U. So here what do you get? Minus V is plus V divided by U is minus U. So you will get a magnification. See, V is equal to U, this will give you plus 1. How did I get plus 1? Because the value of V and U are equal, and minus minus cancel, I will get plus 1. So you can say the magnification produced by a plane mirror is plus 1. What is the meaning of plus 1? Magnification 1 means the size of the image and the size of object are equal, and plus means the image is not inverted, image is erect with respect to the object. See, object is upright, image is also upright. So this is basically image formation in a plane mirror. Now we will take up image formation in a concave mirror. See, in the case of a plane mirror, you had only one diagram, but for concave mirror, you have something like 6 to 7 different diagrams. But we will discuss only the very basic method of doing any diagram. Fine. In a concave mirror, you need to think about various possibilities, that this is the concave mirror, this is the principal axis. Okay. In a very simplistic way, one light ray can come from infinity parallel to the principal axis like this. A light ray coming parallel to the principal axis will reflect and go through the principal focus. This is the first diagram that you need to study. Fine. In the second diagram, you have the concave mirror, you have the principal axis. Okay. What will happen if the light ray passes through the focus? So you have your focus point here, the principal focus. What will happen if light ray goes through this? You can see it's almost similar. Here the light was going through the focus. Here it is coming through the focus. Then this will go parallel to the principal axis. That is the second point that you need to understand. In the third point, you have your concave mirror. This is principal axis. Consider one light ray which is going to the pole. What will happen if it is going to the pole? You should remember that this is a spherical surface and there is the center of curvature. So this become a radius, and we know radius is actually normal at that point. So this radius become the normal, or the principal axis become the normal at the point pole. So this angle will be the angle of incidence. So the light ray will make an equal angle and reflect like this one. This will be equal to I. Actually this is the angle of reflection. It is equal to I, and the light ray will go like this. So these are the three basic diagram that you need in the case of concave mirror. I'll add few more. Okay. Now here you have the concave mirror. This is the principal axis. This point is pole. This is focus. Where will you mark center of curvature? We know focal length, double the focal length is center of curvature. So you can mark center of curvature here. Okay. Now what will happen if a light ray passes through the center of curvature? Suppose one light ray go through the center of curvature and falls on the mirror. We know that this is the center of the sphere. So this become a radius, and the radius is a normal. Right. So this is falling along the radius. So this is called normal incidence. It is called normal incidence. In normal incidence, you should know angle of incidence equal to 0, angle of reflection is also equal to 0, meaning the ray which was going in this direction will retrace its path backward. So these 4 diagrams are very important to make a different image formation in a concave mirror. Alright. So in the image formation of concave mirror, we have these 4 basic diagrams. Out of this, most commonly or most useful are the first one and the third one. These are the 2 diagrams that we repeatedly use to form images. Now we will go to convex mirror. Fine. Next we will discuss image formation in a convex mirror. Okay. Consider a convex mirror. This is a convex mirror. This is the principal axis. A light ray coming parallel to the principal axis. This is the light ray coming parallel to the principal axis. It cannot go through the mirror because mirror is actually an opaque object. Fine. Mirror only can reflect. Now this light ray will get reflected like this. It will get reflected like this. And for any observer watching from this side, this will appear to be coming from a point on the principal axis. And now we know that point is what we call as the principal focus. This is the principal focus. So a light ray which is parallel to the principal axis will appear to be coming from the principal focus. Okay, that is the first diagram. Second one, in the second one, this is the convex mirror. What will happen if a light ray, say the principal focus is here. What will happen if a light ray is falling to the mirror so that its line is towards the focus. So a light ray is falling like this. If I extend it, it would go to focus. What will happen to this light ray? This light ray will reflect parallel to the principal axis. It is actually the reverse of the first diagram. Here the light ray was parallel, but it reflects so that it appears to be coming from the focus. Here a light ray directed towards the focus will go parallel to the principal axis. Next one, same convex mirror, principal axis. What will happen if a light ray falls at the pole of the mirror? Just like the case of concave mirror, this will also reflect making equal angle. This will also make an equal angle, reflect. This is the angle of incidence, this is the angle of reflection, which should be equal to angle of incidence because this is the normal. This principal axis is the normal. Fine. Next, this is convex mirror, this is principal focus, this is center of curvature. What will happen if a light ray is directed towards the center of curvature? Say a light ray coming like this. If I extend, it would go to center of curvature. What will happen to this light ray? Again I tell you, this line is actually radius. Radius is normal, so this is normal incidence, so the light ray will simply bounce backward. So these are the 4 basic diagrams for image formation in a convex mirror. Now we will just do 2-3 different image formations just to understand what is happening. Okay. First case, consider a concave mirror. Consider a concave mirror. This is the principal axis. Say this is the principal focus. Almost double the length, you can mark center of curvature. And we should know center of curvature is twice the focal length. Now assume that there is an object kept here, an object which is away from the center of curvature. How to draw the image formed? First of all, I will take one light ray parallel to the principal axis. Okay. This light ray, as we studied, will go through the focus. This is the reflected ray. The second one, most convenient, is you can take one light ray from here and you can send that to the pole. From the pole, it makes an equal angle and this will go like this, make an equal angle. Now we can see these two light rays after reflection, they meet at this point. So this is where you are going to get the image of this point. So if I call this image as AB, this point will be the image of A, which is A dash, and the image will be formed here in the inverted manner. I can see this is the mirror. Both object and image are on the same side. Object is upward on the principal axis, but image is downward. So we say image is inverted. And if you compare the sizes, we will see that the image is smaller in size than the object. So this is one image formation in concave mirror. The second one is like this. You have a concave mirror. This is the principal axis. This is principal focus, center of curvature. What will happen if you place an object here within focal length between pole and the principal focus? Just like we did earlier, we will take two light rays, one going parallel to the principal axis, and that will reflect through the focus. The other one will go to the pole and make an equal angle and will go like this. Now we should see that in the previous case these two light rays were converging and they could meet at a point, but here they are diverging, they can't meet. So the person who is watching or who is receiving this light ray will experience like these rays are coming from behind the mirror. So how to get that mathematically? Mathematically we will do like we will extend this backward, and this will also be extended backward. So when extended, these two rays will meet here. So this is where you get the image of point A. Image of point A is here, that is called A dash, and B is here, image of B will be here, B dash. So we can see the image is upright, object is also upright, both are upright. This is a magnified image, this is a magnified image. So a concave mirror has the ability to form inverted images and erect images. It can form images smaller than the object, images larger than the object, and even images of same size. So the magnification of concave mirror is very versatile. It makes it's a very good application in many areas. Now we will take a image formation in convex mirror. Consider a convex mirror. Convex mirror, this is the principal axis, and for the convex mirror we know center of curvature is behind the mirror. This is where you have the principal focus. Let us place an object on the principal axis here like AB, okay, a real object. Just like we did earlier, one light ray will go parallel to the principal axis, will fall on the mirror, and what will happen? This light ray cannot go behind the mirror. This will only reflect. It will reflect such that if extended, that is coming from the focus. So this is how it goes. Now another light ray which is hitting the pole will reflect at an equal angle. So if I extend this one backward, because for the observer here this light ray is appearing to be coming from behind the mirror, that's why we extend it backward, and I get a point here. This is the point where you get the image of A. I call it as A dash. And if you take if you do the same thing for other points, you will get the image here like this. This is the image A dash B dash, and we can see it is smaller in size. It is erect with respect to the object, and it is behind. So we will say this is a virtual image. It is smaller in size. It's always erect. Convex mirror will produce only one type of image. It's always virtual, always erect, and always smaller in size. That is one of the reasons why we use convex mirror as a rear view mirror in a vehicle. It always produces smaller. You must have seen on the mirrors of bike, it is written objects are closer than they actually are. It is this reason. Okay, now let us do one numerical question on this. Consider a concave mirror. where radius of curvature is given as 30 centimeter. And it is given that there is an object at 30 centimeter from the mirror. It is asked, find the nature, position, and magnification. Find the nature, position and magnification of the image. This is what you have to do. I told you before, questions in optics are difficult because of that sign convention. So we have to apply sign convention in this question, Cartesian sign convention. Let us make a rough sketch of what is given. I have a concave mirror. So this is a concave mirror. Okay. It is given radius of curvature 30 centimeter. That means this is the center. This is at 30 centimeter from the mirror. And the object is kept. Object is kept at 30 centimeter. Object is kept here. Object is kept here. I mark object using a vertical arrow mark. Now, what are the equation that we have? We have equation for focal length, image distance and object distance like 1 by f equal to 1 by v plus 1 by u. And for magnification, we have an equation. Magnification is given as m, which is given by h dash by h, which is given by minus v by u. But all with the Cartesian convention. Without that, you can't apply this. To apply Cartesian sign convention, it is important to know the direction of incident light. Okay, what is the direction of incident light? That is always from the object towards the mirror. So this is the positive direction that you should take. From where will you measure distances? All distances must be measured only from the pole. Everything from the pole. Okay. Now, what is u? How much is u? What is u? U is the object distance. And what is object distance? Object distance is from the pole to the object, and that is given as 30 centimeter, and that is opposite to the light. Light is going from left to right, but you are taking measurement from right to left. So that must be minus 30 centimeter. Pause for a moment and think, why is it minus? Because if you think and if you get an answer, that means you know it. U is minus 30 centimeter. Now, what do you want? You need to find the position of the image. You don't know the position of the image, so you don't know V. You have to calculate V. But do you know what is F? What is F? F is not given. But we studied that F is equal to R by 2, where R is the radius of curvature. And what is R? Radius of curvature is the distance from the pole to C, and that is minus 30 divided by 2. So you will get it as minus 15 centimeter. So you got focal length minus 15, you got u minus 30. Now let us apply that in the equation. Okay, take the equation 1 by f equal to 1 by v plus 1 by u. Out of this, you know f, you know u, you don't know v. So we can take a v on this side. 1 by v is equal to 1 by f minus 1 by u. Now apply with the sign. What is f? F is minus 15 minus, what is u? Minus 30. This is minus 30. Okay, I'll do the rest here. This is actually 1 by 30 minus 1 by 15. 1 by 30 minus 1 by 15. 1 by v gives you minus 1 by 30. Just flip them. You will get v equal to minus 30 centimeter. So we got your image position minus 30 centimeter. Okay, let us go back to the diagram and see where this is minus 30. In your diagram, minus is leftward direction, opposite to the light. So this image is at 30 centimeter to the left. That means the image is formed here at C itself. Okay. The image is formed here at C itself and the image distance is minus 30. Next thing, we need to calculate magnification. How to calculate magnification? It is minus V by U, which is minus of V is already minus 30 divided by what is the value of U? U is also minus 30. U is minus 30. So this gives you minus 30 by minus 30 is 1. You will get minus 1. Magnification is minus 1. What is the meaning of magnification? 1. 1 means same size. What is the meaning of minus? Minus means it's an inverted image. So the question, what is the nature? What is the nature? Nature is the image is inverted and equal size. And what is the position? It is 30 centimeter from the pole. And what is the magnification? Magnification is minus 1. This is how we apply Cartesian sign convention. This is a very basic question in NCERT textbook. I hope it's clear.